Everybody say hi, Kiera and Jason.
No.
They don't like you very much. Okay, this is section 4.2, real zeros. So we're going to get through part of this. It takes a little while to do these problems, so we're going to get through about half of this. And it's kind of hard for me to explain to you. So, full and undivided attention, here we go. I want to draw your attention to this thing, which I call the P over Q method. This is unpleasant. I'm not going to lie to you and sugarcoat it and say that it's going to be nice, because it's not. So I need your full and undivided attention. The P over Q method, okay? Sometimes factoring things does not work. Sometimes you cannot break them down. Sometimes it's not very nice. And sometimes you have like big, long functions like this that can't be factored down, right? We don't have a factoring method to break down something that's 5 terms long, right? We can do like simple trinomials and complex trinomials and difference of squares and all that good stuff. But we don't have a factoring method for something that is 5 terms long. So what we can do is something called the P over Q method. All right, we're going to label this first example right here. And I'm going to tell you what is P and what is Q. And this is the only thing we care about right now. Ready?
Wait, is this,
the 6.
Okay.
The 6 is P. The 2 in the front is Q. Now, it will not always be the first term and the last term if it's not in the correct order. If it is in the correct order, it will always be the first term and the last term, okay? So it's the leading coefficient and the constant term. P is always the constant term. Constant term. Okay, P is always that guy, and Q is always the leading coefficient. I'm going to just label him LC, okay? Now, be careful because sometimes it will not be in the correct order. So it has to be in the correct order in order for this to work, okay? P and Q. Now, P goes on the top, Q goes on the bottom, okay? So here's how this works. We put 6 over 2, right? Oh. P goes on the top, Q goes on the bottom. I'll show you how this works. I'm gonna move this over a little ways so we have a lot of room. We gotta have a lot of room. No, don't reduce it. Just wait. Okay. I'll show you, okay? P is this number, Q is this number. 6 and 2. It's the ending number. I'm going to do that. Ending number over the beginning number, right? End over beginning. End over beginning. It's kind of like the y's over x's, right? End over beginning. It's weird, okay? 6 over 2. Now, here is what we do for the P over Q method. Are you ready?
Sure.
Okay, this is very hard for me to explain to you, okay? All right. Here we go.
Where did you put our homework that we just turned in?
I don't know.
My work is right here.
Okay, just put it there, up there.
It's right here.
Just put it up there. Okay. All right. Are you ready for the next step? Okay. Look at just the number 6. Just the number 6 for right now. What numbers are factors of the number 6? Meaning, what numbers go into 6? Let's start with the with 1. Okay. 1, 2, 3, and 6. Yes. Okay. Now the reason why I spaced them off that far is because. Hold on. I spaced them out a little bit because 1 goes into 6, right? Does -1 also go into 6?
Yes. Yeah.
Like, what would I have to take times -1 to give me 6? Like -1 times -6, right? So, not only is 1 a factor, but positive and -1 are all factors, right? Is -2 also a factor?
Yes.
Is -3 also a factor? Is -6 also a factor? So, how many numbers go into the number 6?
8.
8 numbers, technically.
8.
Yes, there's 8 numbers that technically go into the number 6, okay? Now, let's go with the bottom one, which is the number 2.
1 and 2.
1 and 2, but positive and -1 go into 2, and positive and -2 go into 2. So there's 4 numbers.
So then you can
Okay, just wait. No. Just wait.
Just be quiet.
Okay, are you ready? This is the P over Q method, okay? All right, you do this process every single time you do the P over Q method, okay? And the more you do it, the faster it becomes, right? Like, this isn't a very long process. Well, yet, okay? Now, here's what we do. We look at fraction-y things, okay? So we look at, like, this is my first fraction. 1 over 1, which reduces to be 1. This is my overall final list, plus and minus 1, okay? Then I do 1 over 2.
Oh, what?
Which is plus and minus 1/2, right? You see that? This is going to get nasty. You see it? It's not going to be too bad. It's not going to be too bad. Okay? Then the next one. We have 2 over 1, which is plus minus 2. And then we, hold on, just wait a second. Because some of them are going to repeat. Look at 2 over 2. Is 1, but we already have 1 in the list, right? So we don't have to write them twice, okay? So it's not going to be as long of a list as you think it is, right? Okay? Okay, it's still kind of gross. So we have 3 over 1. I'm going to do a different color. So this is plus and minus 3. And 3 over 2, which is plus and minus 3 over 2. Okay.
And then
Next.
plus minus 6.
Okay. Next, we do, I'm running out of colors here.
3 again.
6 over 1, which is 6, and 6 over 2, which is 3 again, but we only have to write it once. So plus minus 6. And then plus minus 3, but that was already written right here. Okay. So this is my big long list. How many numbers are in that list?
12.
There's 12 numbers in that list. Okay, now here's the deal. This is the very most important thing. The list that we've just created with the plus and minuses, that is 12 numbers. Are you ready for this? Okay, these are all the list of possible zeros. They are possible zeros. And here's what I mean by that. If the number is not in this list, there is no way that it could be a 0. Like the number 5. The number 5 is not in this list. So there's no way that 5 could be a 0, right? These are the only ones that could possibly work, right? The number 4 is not in this list. The number -4, the number 7 is not in this list, right? Those are not possible zeros. These are the only ones that could possibly work. Now, this is only an x to the 4th power function. So maximum, I'm going to have 4 answers, right? So it's not going to be all 12 of these. How do you figure out which ones work and which ones don't work? Okay? So to see which ones work, you plug in and it must equal 0. That's how you check to see which ones work. Now, no, hold on. There are only a few on your homework assignment that I actually make you do start to finish. Like there's maybe 2 of them that I actually make you plug them in. Otherwise, there's a couple of them on your homework assignment where I just say list the possible ones, okay? So pay close attention on your homework to whether I say list me the possible ones, in which case you come up with this list, or actually plug those in and let's find which ones actually work, right? Okay? All right, so what I'm going to do down here, find all possible zeros. Okay, so we've come up with our possible list. This is the same function as above. Now we're going to plug them in, all right? And we're going to divide and conquer. Are you ready? Can we divide and conquer a little bit?
Yeah.
Okay, so hold on. Let's do this. Let's do this. Just no. Just wait. Just wait. Plus minus 1. Plus minus 1/2. Write this list out again, and we're going to circle which ones work. Write this list out again. We're going to circle which ones work. Okay, those are my 12 numbers that I came up with, the possible ones, right? We're going to divide and conquer here in a second, all right? There are 6 tables, and I think I'm going to lump Gracie maybe with Clayton, so we have 2. Oh, and Jason's back again, so he can be with, okay, yeah, we'll be good, okay? All right, so here's what we're going to do. We're going to divide and conquer, and you need to make sure that whatever number I give you to plug in, you plug it in good, okay? And you plug it in, and like it's not like you do a good job plugging in, okay? So I don't have to repeat these, all right? Are you ready? Who wants 1 and -1?
Me.
That's an easy one, okay? Your table gets 1 and -1. Hey, do you know what you're plugging into?
Dang it, Casey.
Into this function.
That's what I wanted.
Into this function, you're plugging in 1 and -1. All right, who
We'll
wants
take
1/2?
2.
Who wants 1/2?
We'll take 2.
Nobody wants 1/2?
We'll take 0.
You don't have 0, child.
Okay,
I
we'll
got
take
0.
3. We'll take what do you want?
Okay,
We'll
hold on.
take 2.
We gotta do 1/2 next. 1/2.
No, half.
I trust Emma and
No! Rachel wants 6.
Now you can plug in 0.5 instead of 1/2. That's fine.
Bro, I didn't even have my calculator. I was
Well,
going to
take
do
two.
right, and I
Take
hate
two into this
school on my
function.
paper.
So, you want positive and
I'm
negative.
sorry,
Positive
Rachel.
and negative. Okay, you guys
It's
get
negative
2.
not
You're plugging in
Mine
2
is
and 2.
negative.
Okay,
I
the
got
positive and the negative. Woo!
We got 3.
Three,
We
you guys
better
want
not get no
Can I trust you guys to do
fraction.
1.5?
Positive, you do negative.
3/2, 1.5. Okay,
It's
and
not
6.
1.
You guys have 6s.
Okay, wait.
Plug in 6s. Both of you do it so that you can get an answer. Right?
You get negative 1. I got 0.
How do you do a fraction again?
All right, we're plugging these in. Just do 1.5 as a decimal.
2.
So you're plugging in 1.5 and you're plugging in negative 1.5. Now, as you're plugging these in, what are we looking for?
0.
0. They want to come out to be 0.
Oh.
Okay?
Yeah, we got 0.
Hold on. Okay, so keep that in mind. I'm going to go through the list and you're going to tell me that. Okay, so do the minus and see if the minus works. Okay?
All right, Rachel, you do
Wait, do I need pun?
Hey, Clayton, do both of them.
Do I need
I will
pun?
Do
be
both of
very
them so you can
grateful
check.
for you,
Okay.
Rachel.
Do I need pun?
Yes, yes.
Did you do
I would do it just like
positive
that.
or negative?
Okay? Okay, plug them in. If you're watching this video, skip through until we start going through and listing out which ones work.
Ha! That's a no because I knew it already. I really just don't understand why we don't graph them. Like,
Because graphing them, you're finding the approximate one. I can tell you exactly what the number is.
but yeah, but like,
Like 1/2 and negative 1/2, you might round it off to be like 0.4
You
and
don't
stuff
even
like
know.
that. Right. Or
but
like
I'm
this
saying
is
like if
especially
you
true.
find the
This is
possible.
especially true when it comes to thirds, right? Like thirds don't round
Yeah,
off nicely,
30.
right?
Yeah.
So like you might round it off to like 0.68 or something
But
like that.
if you find the possibles, then you can graph and be like, okay.
Kind
so-
of, kind of. Yes, you're right. Right. But I'm just showing you that like this works. Okay.
What if I don't get zeros?
Then that's fine. That's fine. We're just wanting to know which ones come out to be 0. Have you plugged yours in?
And I have to keep the
Has everybody plugged theirs in?
Yeah, we're done.
Okay.
Give me a shot.
Okay, I'm gonna start going through the list. So listen up and circle the ones that work and which ones don't work. So 1 and -1. So I'm gonna cross them off. 1, -1 doesn't work. So none of those work. 1, -1 is out. Okay. Positive 1/2.
Yes.
Positive 1/2 works. What about negative 1/2? No. So right now I'm gonna list positive 1/2. That is one that works. How many total possible could work?
4.
4. All right. 2. Positive 2, -2.
No.
Neither of them work. Positive 2, -2. Okay, so 2s are out. 3. Who had my 3s? What? -3 works, but positive 3 does not. Okay, so I'm going to put -3 here. All right, 1.5 or 3/2. Any of those work? Neither of them? Okay, perfect. Okay, 6s.
They should both work.
Neither.
Neither of them?
Cross out the 3.3 over 2.
3/2, yeah. Okay, so we only have 2 of them. And we should have 4, right?
But if the W is
I think that -3/2 should work.
Right. So what could happen is, like, let's say I have this happening and you only have 2 crossed, right? What are these other 2 called where they cross?
False.
Alright, here's the thing.
Imaginary. Right?
graph
That's what could
crosses
happen.
4 times.
It does cross 4 times? Where?
The first one is -3, and then
Okay, we're going to talk about that in your
negative
Problematic
point, so
child.
negative
You know that?
2/3.
Yeah, you've had a lot of problems.
0.5, so 1/2. We got that one.
Uh-huh.
And then
Right.
2.75.
Okay.
I have had no, I am.
So
2.75?
Yeah.
Okay. All right. So, hold on. So we have 2 of them, yeah?
No.
Now, here's what could happen. The other 2 could be imaginary, or they could be really ugly decimals, right? Okay? They could be like irrational, meaning like square roots of stuff, okay? So, listen, I'm going to say that again. Your other 2 are either imaginary or they're really ugly decimal ones, okay? So here's the deal. We're going to keep going with this. Here's my 2. Those are the 2 that come out nicely, yeah? Okay? All right, so let's move on down. I'm going to take up like this whole page for one problem, okay? All right. What we're going to do is we're going to start with this function right here, and we are going to use synthetic to divide off the 2 that we know work, right? Okay? We're going to divide off those 2 that work perfectly. All right, so here we go. Synthetic. I have, which one do you want to do first? 1/2 or -3? -3. Okay. Put the -3 on the outside, and we've got 2, 1, -17, -4, and 6. There we go. Okay?
Make it a 3. Don't you flip there?
No, because this is what x equals. It's already flipped. It's already flipped. Maybe so. Okay? All right, we're going to synthetic divide this off. Emma Carr, come on.
Yep, that's
Yep.
my name.
Emma Carr, come on. 2 drops down. Here we go. -3 times 2, -6, -5, +15, -2, +6, 2, and -6 and 0.
No, you don't.
There you go. Okay? Good?
Wait,
Hold on. I'm sad.
Oh,
There you go. There's your synthetic. We've divided off the -3. Now let's do it again. And I'm just going to do this. Synthetic division twice, right? Can we just do synthetic division off of that guy again?
No, that's weird.
No.
Yeah, it is kind of weird, but that's okay. We can do it, right?
What are you talking
It's going to be okay.
What are we doing?
We're doing synthetic division off of another synthetic division. We're doing it twice,
That's illegal.
right? There's no reason for me to rewrite it again. It's going to be the same numbers again, right?
No, it's not this. Oh.
Yeah, I'm doing synthetic. Yep. Okay, so now we're going to drop the 2 down. 1/2, what's half of 2?
1.
1. -5 and 1 makes -4. What's half of -4? -2, that makes -4. And what's half of -4? -2, so we have 0. We have 0. Okay? All right. Woo! Okay, let's put our x's and such back in here. So this guy, this is 2x to the what?
Third.
We started with 2x to the, we started with an x to the 4th, but how many numbers did we divide? 2 of them off. So this should be x to the 2nd now, right? Minus 4x to the 1st minus 4, right? Now, do you know how we break this guy down? We're not, but do you know how we would break it down?
Take 2 times.
He's a complex trinomial, but I don't think he even breaks down as a complex trinomial.
Take 2 out of everything.
Right? You could take 2, I mean, you would have to use the quadratic formula, which means he doesn't break down very nicely. So when they say up here, find all the zeros, or they said completely factor. Let's do this. Let's completely factor it down. My factors will be x minus 1/2, x plus 3, and 2x squared minus 4x. Is it minus 4? Minus 4.
Oh my God.
Those are my factors, because this one doesn't break down nicely. Now, do you see how I got the x minus 1/2 and the x plus 3? We flip the sign there. This is him completely factored down. You see that? That's completely factored down.
This makes me want to.
This is craziness. So, when you find your 2 that are really nice, maybe they all 4 come out really nice. Then you're just stop, right? You don't have to do synthetic division. But you synthetic divide off the ones if you have 2 remaining, and then just write the remaining factor that's left over. Make sense? Yeah, kind of. This is a lot of stuff. This is a lot of stuff. What?
Fried.
Like for this one.
Oh.
How much was
Right, to find the other 2. Right.
22.
Okay? Good? Yes?
Why? It's not that bad.
All right. I'm trying to think of what I want to do here.
You are correct, Rachel. You don't, but whenever you're
What'd you
up
get?
on the 36 board, we'll know you got a 36.
Yeah, let's do this one.
What?
What'd you get?
Did you get
Me?
it? Did you find out?
Rachel. She won't
She won't tell us.
Is it good?
But she's smiling. I think it's good
Probably
because
like
she's smiling.
She had it.
She doesn't have to tell you.
But I guess
She
I was
doesn't have to
guessing it.
She doesn't have to say. All right, let's do this one and then we'll stop. I'm gonna skip this example right here, example 4.
Rachel, whatever you got.
Draw a line through example 4. So if you need extra room on example 3, use it. Okay, we're gonna completely factor this one down. How many answers should we have?
All of them.
5. There should be 5 of them. Okay, so we're gonna completely break this one down just like we just did, but it's gonna be a little faster because this is like the second time around, so we can do it a little faster. Cross out example 4 because we're gonna get rid of him. Okay, completely factor down that thing. All right, here we go. We should have 5 of them. So we do P over Q. Which
9
number is P?
9 over 5.
9 over
2.
2. 9 over 2. Okay, list out factors of 9. What numbers go into 9?
9.
1.
Plus minus 1.
Plus minus 1. Plus minus 3.
Plus minus your mom.
Plus minus 9. Those are the only numbers that go into 9, yeah?
Plus
Okay.
minus
On the
1.
bottom, we have plus minus 1 and
Plus minus 2.
plus minus 2. Those are the only numbers that go into 2. Okay? So now we start making our bubbles here.
Plus minus
1 over 1 is 1, and it's plus minus 1. 1 over 2 is 1/2, so plus minus 1/2. Okay? 3 over 1 is plus minus 3. 3 over 2 is plus minus 3 over 2. 9 over 1 is plus minus 9. Plus minus 9. 9 over 2 is plus minus 9 over 2. Okay, let's write out our decimals though here. 1/2 is 0.5. 3 over 2 is 1.5, and 9 over 2 is
4.5.
4.5. How many possible How many possible ones could I get? 12. Those 12.
No,
Okay.
5.
We're going to test them and see which ones we have that are nice.
Derrick Henry carried.
All right. So I'm going to write this list out. Plus minus 1. Plus minus 1/2. Plus minus 3. Plus minus 3 over 2. We're not doing example 4. Plus minus 9. Plus minus 9 over 2.
Seems as if it
Okay.
only hits
All right. We've got 12 of them again, which means we have 6.
We want one
Stuff.
again.
Nope, you're not going to get an easy one again. The people who had
We
fractions
want
before
one.
are going to get
Well,
non-fractions.
Yeah,
No.
we'll take one.
You guys get 9 over 2.
We'll
No.
take one.
That is
We'll
4.5.
take
No,
one.
no, 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 no,
Rachel
no.
gets one because she's number 1.
You're
So
not.
We'll take
Rachel gets
0.5.
one.
You're done.
We'll take
This is what I
0.5.
got.
Rachel gets one.
All right, I'm going to give these to you. Ready? Here you
Rachel
go.
gets
To
one.
us first. Me and Clayton want 0.5.
We want 9
She
or
don't
3.
care.
Okay, Marcus and Craig, into that function, you're going to plug in 4.5 and negative 4.5. You guys get
That's
1.5,
That's low.
1.5,
We'll take
and
one.
you guys get 0.5. So
We'll take
1
one.
half. You guys are doing 1/2.
No.
5, okay?
We'll take
you guys
one.
can do
I'm
1.
doing positive.
You guys got 3 and negative 3. You guys got 9 and negative 9. 9. 9. 9 is just as easy as 1. Okay.
Example 3.
Example 3. It's the 5th power one. This run right here you're plugging into.
Negative
Woo.
1.5.
Sorry, Kira, who's watching this video. This is kind of rowdy here. It's crazy.
Look what we're doing.
Okay, I know it's crazy. I told you this is gonna be unpleasant. I told you. I
Why are we doing
forewarned
it?
you. I forewarned you.
I got no forewarning. What do you mean?
This is what I got, and it is not 0.
Okay, keep that in mind.
No.
Okay, so when I go through the list.
No.
Hey.
0.
Craig, you are not plugging stuff in, child.
Wanna bet?
Where? Where is
I
your
got-
calculator?
Not 0.
Okay, well
I
then
didn't
half
have
is
0.
out.
I got 0.
I'm not even halfway through plugging it in
Half
yet.
is out. We didn't get 0.
Sad hole. Perpendicular learning.
You know what we need to do?
I think I
Perpendicular learning.
Get some leather polish and polish up that recliner.
Yeah, I have
Last
some.
time, if you could make it
Hey,
just
don't do that.
easier because you can just
Don't do that.
Perpendicular learning.
Kelsey,
Perpendicular learning.
It's gonna take these
that is
people, like,
not
14 hours.
perpendicular learning.
Ah,
None.
none include the whole thing.
Okay.
Turn that way.
Go up.
Wait,
Hit the
let
up
me
arrow
turn
and then
the
do back to it.
table sideways.
That was pointless.
Let me just.
No, it's not. It's
I think I
like
should
gone.
Oh.
Perpendicular learning.
All right, who had 1 negative 1?
I wish I knew whose bottle cap that was.
We
What?
are not done yet.
All right.
Ours are none.
She's about to yell at me.
All right, we'll
And
work
she's starting to
backwards.
yell at
We'll work
me.
backwards.
None.
9 halves is none and none, so none. Okay?
None.
Do we have 9s? None?
I got a big number.
None? None for 9s? What about 1.5 or 3 over 2?
No. Positive. Oh,
But negative is yes?
we don't know.
Clayton messed up.
Plug it in. Go. We'll wait for you. Positive is a none. Okay, we'll check on negative here in a second. 3s. Who had 3s?
Us. Positive works, negative does not.
Positive works, negative does not. So we have positive 3 as one of them. Okay, positive 3 is one of them. Okay. 1/2.
No.
None, neither.
No.
1s.
Negative works.
Negative 1 works. Beautiful. 3 and negative 1. And I'm looking at the graph here, and I'm going to say the other ones don't work because look at where it's located. Right here is 3, and here is negative 1. Yeah? So this is the only 2 that we have, which means that the other ones are
Dumb. Icky.
imaginary. The other ones are imaginary. Okay, so if we completely factor this thing down, what does this factor look like in the bubble?
X plus 3.
X minus 3. What's this one look like? X plus 1. Okay. Now we have to figure out what remains if we take those out of this guy. So let's do some synthetic, right? Okay. All right. Synthetic twice and then we're done. Here we go.
2.
2.
Negative 10.
Negative 10.
7.
7.
13.
13.
3.
3.
9.
9. And are we going to do 3 or negative 1 first?
Negative 1.
Fine.
Negative 1. Sure. Okay. Here we go. Drop the 2. Negative 2. Negative 12. Positive 12. 19. Negative 19. Negative 6. That's not right. What did I screw up on?
You didn't multiply 19. Oh, yeah, you did.
You have to add these. Ow!
Is that a negative 10? Oh, do we have to add any zeros?
No, we didn't.
No.
2,
Negative 10 minus
negative 10,
12
7.
times 1.
Is that a positive 13?
It's
Yep.
supposed to be
3 and 9. Okay. All right. Maybe I didn't do something wrong. I don't know. Negative
It
12,
doesn't work.
12, 19, negative 19. Yeah, okay. Negative 6, positive 6, 9, negative 9, 0. Okay, I just was forgetting that 0 on the end there. Okay, anyway. All right. Go down to the next one. Yee. Let's do 3. 3 goes next. Okay, we're just branching off of him. 2 goes down, then 6, then negative 6, then negative 18, then 1, then 3, then negative 3, then
Oh my gosh.
negative 9, then 0. Okay, so let's put our numbers back in there. This is what's left over.
God, 2x.
What is the x on the 2? The third, right? Because we divided 2 of them off. All right, so that's it. 2x to the third minus 6x squared plus 1x minus 3.
Trace.
This is completely factored down. Do you see that? Yeah, there we go. Okay, that's all. All right.
Finish me at 1 minute.
Woo.